Good morning, my dear students. Today, I am going to discuss tricks to solve NEET questions. Under this heading, today I am taking the fourth unit, the chemical bonding and molecular structure. For the last 6 years of NEET chemistry, what are the questions that is asked from the chemical bonding and molecular structure? I am going to discuss. So let me start now. I am Dr.R.G, Professor of Chemistry, who is taking class for you. As usual, my dear students, kindly follow. So, if you want to answer all the questions from chemical bonding and molecular structure, what are the topics you have to study? So, first one, ionic bonding. What is ionic bond? What are the characteristics of ionic bond, characteristic properties of a molecule containing ionic bond? And under this, Fajon's rule. And second, you have to study covalent bond. What is covalent bond? Characteristics of properties containing covalent bond you have to study. Also, the most important is this types of covalent bond you have to study. Under this, there are theories of covalent bond. What are the theories under covalent bond? Kindly follow. To understand covalent bond in detail, it is necessary to understand the following theory concepts. Namely, 1. Lewis theory, 2. Sedgwick-Bowl theory, and 3. Valency shell electron pair repulsion theory, 4. Valency bond theory or valency bond orbital theory, hybridization concepts, and molecular orbital theory. So these all the theories should be studied to understand the covalent bond. Please follow. So, the next you have to study coordinate bond. Then hydrogen bond you have to study. Metallic bond you have to study. This is the syllabus as per our NEET syllabus. Please follow. So, let me go for now. As usual, the first question asked from the NEET. So this is the question asked in year 2016. What is the question? Kindly follow. Let me read the questions. Predict the correct order among the following. A. Lone pair greater than lone pair bond pair greater than lone pair. Number 2. Actually, they have to introduce a word that is missing. Lone pair repulsion. It should be there. But it is missing. Bond pair repulsion greater than lone pair repulsion greater than lone pair. Then C. Lone pair greater than lone pair greater than lone pair. And fourth priority, lone pair greater than lone pair greater than bond pair. This question is very, very simple question. It is a direct question from the postulates of valence shell electron pair repulsion theory. Second postulates. Kindly follow now. So as usual, it is my duty. I have to indicate this is the question asked under the chemical bonding and molecular structure. Specifically, this question is asked under valence shell electron pair repulsion theory. So it is my duty. I have to explain the valence shell electron pair repulsion theory. What is valence electron repulsion theory? There are 5 postulates. So this is introduced by Needham and Gillespie in 1957. Postulates number 1. If the central atom of a molecule is surrounded only by bonding electron pair, please borrow bond pair, usually represented by BPS, and not by non-bonding electron pair, LPS, the geometry of the molecule will be regular, depending upon the total number of bond pairs That is, so they have given very clearly, it will be linear, triangular, planar, tetrahedral, trigonal, bipyramidal, and regular octahedral for 2, 3, 4, 5, and 6 bond pair. That means 2 bond pair linear, 3 bond pair triangular planar, 4 bond pair tetrahedral, 5 bond pair trigonal bipyramidal, and 6 bond pair regular octahedral. Obeying this Rydberg bound theory, kindly follow. Now answer is, the second postulate is our answer, kindly follow. According to valence electron repulsion theory, when central atom in a molecule is surrounded by bond pair and lone pair, the molecule does not have a regular shape. That means a shape is changing. In presence, the additional 2 bond pair, if there is any lone pair, the normal shape expected from the hybridization, it will be changing. So for that, what is the reason? This is due to lone pair bond pair repulsions. This is due to lone pair bond pair repulsions. Kindly follow. So what is the order? They have given very clearly. Repulsion of lone pair repulsion greater than lone pair bond pair repulsion greater than bond pair repulsion. So now we got the answer. Very over. That's all. So this is the correct answer. Lone pair greater than lone pair bond pair greater than bond pair. Directly theory. Anyhow, it's my duty. Let me explain the other three postulates. Number 3, bond angles involving multiple bonds are generally larger than those involving only single bonds. However, multiple bonds do not affect the shape of a molecule. What is the meaning of this? If there are 2 bonds, kindly follow, one is pi bond, another is sigma. So, pi bond will not do harm to the shape, only sigma bond we have to take on account. That is this concept, this postulate. Fourth postulate, the bond angle in a molecule BAB, kindly follow, that is AB2 molecule, decreases with increasing in electron activity of B in AB2 molecule. Simply you just take now, kindly follow, AB2 molecule. So the A is common, kindly follow, A is common. So BAB it is given. So if electronegativity difference between A and B decreases with the increase in electronegative atom in BAB2, the molecule where A is the central atom. Kindly follow, Pi3 greater than PBr3 greater than PCl3. That means P central atom, I BB, Pi. Same way. So the angle, kindly follow, due to chlorine is the high electronegativity, lower bond angle. This is BBr less, higher, still less, higher. So electronegativity increases, bond angle decreases. Very, very important, kindly follow. The next one, 5. Repulsion between electron pair in filled shells are larger than the repulsion between electron pairs in incomplete filled shell. How to understand this? You take oxygen is 2s2 2p4. That means conventionally when I want to write this oxygen, kindly follow, this is oxygen, kindly follow. So this is the 2s2 2p4. Kindly completely filled. There is no 2d. So that means completely filled. Suppose if it is a sulfur, it is 3s 3p, then 3d empty. Kindly follow. So incompletely filled means hydrogen sulfide is incompletely filled, oxygen is completely filled. So what is the postulate says? Repulsion between lone pair and bond pair. So here the only unpaired electron will form a bond. Please follow. Only unpaired electron will form a bond. So repulsion between electron pairs and filled shells are large. Filled shells are larger. That means oxygen is larger than H2S. That is mean H2S, water bond angle is larger than H2S. So question can be asked, kindly follow. So based on this, now we are having a number of example in the table. Kindly follow. Suppose this number 1, total number of pair is 2, 2, 0, hybridization is sp, linear, example beryllium chloride, mercury chloride, carbon dioxide, and that is a N3 minus. Kindly follow, if it is 1, 1, again sp, linear, CO, Cn minus. If it is 3 bond, total number of bond pair, lone pair 3, 3, 0, bond pair 3, lone pair 0, sp2 hybridization. Shape should be triangular planar, example PCl3SO3. And if it is 2, 1, the hybridization is same, but shape is changing from triangular planar to V shape. So stannous chloride SO2. So the next I will go for the fourth one. Kindly follow. In the fourth case, the total number of bond pair lone pair is 4. That means bond pair 4, 0, sp3 tetrahedron, methane example, ammonium ion, sulfate ion, then chlorate ion examples. If it is 3, 1, trigonal pyramid, example ammonia phosphine. If it is 2, 2, bond 2, lone pair 2, V shape, water and F2O. Please follow, if there is any lone pair is present, shape is changing. This is example. So let me go for this again. 5, 5, 0, sp3d, trigonal bipyramid, example PCl5, ClF5, PF5. 4, 1, irregular tetrahedron, that is TeCl4, the tellurium tetrachloride. And 3, 2, it is T-shape ClF3, 2, 3, linear IlCl2 minus. Kindly follow. So the number 6 example, 6, 0, sp3d2, it may or d2sp3, shape will be octahedral, that is spx6, pf6 minus, aluminum AlF6, 3 minus. If it is 5, 1, one lone pair, the octahedral is changing into square pyramid, IF5. 4, 2, it is square planar, ICl4 minus. If it is 7, that is 7, 0, I am stopping with the 6, but only 7 I am giving. sp3d3, 7 orbital, that is 7, pentagonal bipyramid, that is IF7. I hope this you must study. Now kindly follow. I am going to give, please follow, this will not be there in your book. Please memorize these two, kindly note. There are two methods to calculate hybridization as well as total number of lone pair. This is the first method. How to determine? So let me take example of suppose methane. Kindly follow. In the methane, what is the central atom? C. What is the atom attached? 4. Kindly follow. So now what we have to do, whatever any molecule, how to calculate, you have to take A. What is A? A means total number of valence electrons of all the atom in the molecules. So in the molecule valence, what is the valence electron? Carbon 2s2 2p2 4, hydrogen 1 4 into 1 4, that is 8. So A equal to 8. Please follow. Then B, total number of atom attached to central atom, that is 4 is the total number of atom attached to central atom 4. What is C? C equal to B into 2. In the case of hydrogen atom, here hydrogen atom, so 2 into 4 8. Suppose for other atom 2, that is B into 8. Because the the central octet 8 electron, only for hydrogen 2, so we are multiplying with 2 for CH4. Suppose carbon tetrachloride, we have to multiply it by 8. So C is 8. What is D? Please follow. A minus C by T, that is total number of lone pair of electrons. Please follow. Lone pair we can calculate. A minus C by 2. In this case, 8 minus 8, 0. There is no lone pair in methane. Then E equal to, that is giving the total number of hybrid orbitals, B plus D, B4, D0. Therefore, 4 is the hybrid orbital. So, the methane is sp3. Kindly follow. So, this is the way we have to calculate. My dear students, this is one method. You can calculate quickly the total number of lone pair and the hybrid orbitals. So from the hybrid orbitals, we know the shape we can predict two, that is sp linear, sp2 triangular planar, sp3 tetrahedral, sp3d. So everything we have already shown in the table. The second method is this is the most important method. Kindly follow. Determination of hybridization and shape of the molecule. What you have to take the central molecule of central atom of the molecule electronic configuration in terms of the valence orbital alone. That is 2s2 2p2. That is carbon. Please follow 2s 2p. This is carbon. There is no D. There is no D. So according to this, only 2 orbital having 2 unpaired electrons. If it is undergoing the orbital overlapping electrons, only 2 bond form. But actually 4 bond is there. So this is ground state of carbon. Then the excited state, what you have to write now, one of the paired electron getting excited and moving to the next higher empty orbital. Kindly follow. So what is happening now? In this case, the s orbital and 3p orbital undergoing hybridization. So they form sp3 hybrid orbitals. So now there are 4 electrons are formed. So what will happen now? When it is hybridized, the shape will be shape. So I can write like this. Kindly follow. So, this is the hybrid orbital. Kindly follow. That's why, now what is the shape of carbon? Carbon shape this. Kindly follow. This is the carbon shape. sp3, 4 sp3. Now hydrogen is sharing here. So, 4 bonds, sigma bonds are formed. No lone pair of electron. So, we are explaining there is no lone pair present. Please follow here. There is no lone pair is present. In this case, only the 4 sigma bonds are formed. Please follow. Let me come back. The nitrogen, ammonia. So nitrogen ground state. So 2s2 2p3. Please follow. 2s2 2p3. This is the most important. Please, my dear students, carefully follow. So, there are 3 unpaired electrons with the orbital. So, orbital having unpaired electron will form a bond according to valence bond orbital theory. So, here ammonia only 3 atoms are involved. So, this lone pair will not be getting excited. So, now what will happen now? This is undergoing hybridization. What way? 1s plus 3p. Undergoing hybridization, 1 plus 3, 4, sp3, 4 sp3. So what is the shape now? Kindly follow. The shape of this ammonia, now what will happen now? Nitrogen, here hydrogen, here hydrogen, here hydrogen, here lone pair. Please follow. The shape now, because there is a lone pair and again there is 3 bond pair, the lone pair bond pair repulsion is greater. So bond angle is reducing from the tetrahedron. The tetrahedron angle 109.5, that is 5. So now it is reducing to 107. Please follow. It is in the shape of ammonia pyramidal. So what we are identifying now? We are identifying there is one lone pair and the shape also we are predicting. The next, let me take now water. Water again, kindly follow you. Let me take central atom oxygen. 2s to 2p4. Please follow. 2s to 2p4. 2p4. 2s 2p4. So only actually two atoms are form bond with oxygen. So what is the structure of water molecule? HO. Only two bonds. So what is happening here? It is not getting excited. So it is undergoing hybridization as usual. sp3. 4 sp3. The shape as usual. But what is happening? Because there is two lone pair, the shape of water molecule becomes V shape. There is a lone pair here, there is a lone pair here. So two lone pair, the shape is V shape or bent shape. Bond angle is 105.5. Please follow, still lowering. So this is the method you have to determine the bond pair and lone pair and shape. Please apply for any complex molecule using this technique. Let me go for the question now. Please follow. I have given all information regarding this, so I need not repeat further. So question is, please follow. Predict the correct order among the following. According to valence and electron pair repulsion theory, lone pair repulsion is greater than lone pair bond pair repulsion greater than bond pair repulsion. We have seen under this second postulates of valence and electron pair repulsion theory. This is the correct answer. Let me go for the next question. Question number 2, asked in NEET 2016. The pair of electron in the given carbon ion CH3C triple bond C minus is present in which of the following orbitals? A. sp3, B. sp2, C. sp, 2 sp. Please follow. 2p. sp3, sp2, sp, 2p. So this is the question asked. Let me explain as usual under what head topic this is asked. This question is asked under the chemical bonding and molecular structure unit and the specific topic hybridization. So we must know what is hybridization, what are the information we are getting from hybridization. Kindly follow. Pauling introduced the hybridization concept in order to explain equal divalency of beryllium, equal trivalency of boron, and equal tetravalency of carbon. Hybridization concept was introduced by Pauling. What is hybridization? Let me explain. It's a phenomenon in which different atomic orbital having different energy belonging to outermost energy level, only valence shell of central atom, undergo combination to produce orbitals of equivalent energy. Please follow. The new orbitals thus formed are called hybrid orbitals. Please follow. This is the most important. Let me repeat again. Hybridization is the phenomenon in which different atomic orbitals having different energy belonging to the outermost energy level of a central atom. Please follow. Central atom undergo combination, only valence shell of central atom undergo combination to produce orbitals of equivalent energy. The new orbitals thus formed are called hybrid orbitals. So, what is the rules here? Only orbitals of more or less same energy from the valence shells of same atom or ion can hybridize. Only orbitals of more or less same energy from the valency of same atom, that is central atom or ion, can hybridize. Number 2. Total number of hybrid orbital produced is equal to the same number of atomic orbital. If Total number of atomic orbital 4, hybrid orbital 4. If it is 3, 3, 2, 2, like this. Generally, hybrid orbitals have same size, same shape and different same energy. Whereas atomic orbital undergoing hybridization have different size, different shape and different energy. Next, from the type of hybridization, please follow, one can predict the geometry and bond angles of a molecule. Please follow. Once you are predicting the hybridization and also lone pair, you can predict the geometry and bond angles of a molecule. Each hybrid orbital is stronger than both s and p orbital from which it originates. Now, let me give fastly the specific example to understand. Please, this is you have to memorize. This is 1s and 1p undergoing combination to produce 2sp orbital. This is the shape of 2sp. Please follow. S is spherical, p dumbbell, but this is the shape is the equal shape. Kindly follow. The specific example is beryllium dichloride. This is, you can see, beryllium dichloride 2s2, and in the excited state it is going to 2p, so 2 unpaired electrons. So from 2 chlorine atom, 2 electron is shared, it is undergoing hybridization, so 2sp it is forming. Please follow. So what is the shape now? I already told you this is the shape of sp. What is the bond angle? 180. Please memorize. Hybridization is sp, bond angle is 180. This is the linear. Shape is linear shape. Please follow. Let me go for sp2 hybridization. So 1s and 2p. Kindly follow how I have memorizing. Please follow. This is the way you have to memorize. 1 plus 2, 3. 1s, 2p. Kindly follow. 1s, 2p. 2 means again 2p2 I am writing there. So 1 plus 2, 3, sp2. Kindly follow. That means 3 sp2. There is 1 sp2, sp2 and sp2. So this is the way remember. So kindly follow. This is the shape of sp2. So what is the bond angle? Angle will be 120. Please follow. It is the planar bond angle is 120. This is the hybrid orbital. So specific example, if you want boron trichloride, you take example. Boron 2s2 So 3 atoms are attached. So one is getting excited to the going to 2p, 3. So 3 electron from 3 chlorine atom is shared. So mutually shared now. Covalent bond is formed. So it is now the hybrid orbitals are yes, 1s, 2p. So we are getting now, kindly see now, this is the shape of boron trichloride. So the center is hybrid orbital, but is boron. This is chlorine, 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 sharing this electron, sigma, sigma, sigma. So we are getting it is a planar molecule, bond angle is 190. So sp2, triangular planar, bond angle 120. Then going for sp3, 1 plus 3p, as usual 1 plus 3, 4, 4sp3 is a tetrahedron. Kindly follow. Hybrid orbital is tetrahedron. The specific example, let me take carbon tetrachloride. Under the carbon tetrachloride, carbon is 2s2 So one electron is getting excited going to the next empty orbital. Now 4 electron from core chlorine atom coming and hybridized. So forming 4, 1s plus 2p, 3p. So 4 sp3 hybrid orbital. See the shape now? Kindly follow. This is the shape. So this is the shape of central atom of carbon. Bond angle is 109.28. 109.28. So that is the shape. The bond angle shape is tetrahedron. Please follow. If it is a tetra, so we are knowing the shape, we are knowing the bond angle. Please follow. The next, I will go for the next example. 1s 3p plus 1d. This is another involving d orbital also. So kindly follow 1 plus 3 plus 1, 5. 5 sp3d. So this is a shape. It is called triangular bipyramidal. It is triangular bipyramidal. Kindly follow. So example is phosphorus pentachloride. Central atom phosphorus 2s to 2p, 3s to 3p3, 3s to 3p3. So now what will happen now? Because 5 atoms are there, so we need 5 unpaired electron. One is getting excited. So 5 electron is coming from the 5 chlorine atoms. So it is 1s 3p plus 1d undergo combination. So see the combination now. So how it is undergoing this way? This is the shape of hybrid orbital. Kindly follow. It is trigonal bipyramid. So bond angle is, there are 2 bond angle. One is 120, another is 90. Kindly follow between these 3 orbital. Kindly follow this orbital. Kindly follow. Angle is 120. And between one is at the top, another is bottom. The perpendicular is 90. So the bond angle is 120 and 90. This is triangular bipyramid. Please follow. Trigonal bipyramid shape. The next one, sp3d2, 6 orbital. 1s, 3p, 2d. Please follow. This is normally useful when you go for coordination compound. Octahedral forming. So this is the shape of octahedral. Kindly follow. Let me go for here. Example is SF6. Example. Sulfur. What is the electronic configuration? 3s to 3p4. Or the oxygen next sulfur. 3s. But there is 3d. So what will happen now? How many 6 unpaired atoms are attached? Only 2 unpaired here. So both unpaired, paired electron getting unpaired. Now we are getting totally 6 unpaired electron in the excited state. So from 6 fluorine atom donating the single electron, unpaired electron, forming now these hybrid orbitals. sp3 d2 hybrid orbital it is forming. Kindly follow. Now see the shape now. What is the shape of this one? This is the shape. The bond angle is only 90. Please follow. This is, kindly imagine, this is the square planar, central, this is one, this is another, this is another, this is another, this is one, this is two. Imagine square, a triangle, that is, this is a square planar, that is actually octahedral. For your understanding, I will say square planar, that is two orbitals, one is above, one is below. So we are calling it as it is octahedral. So please remember, angle is 90. This is octahedral shape. I hope this is enough for hybridization. Now let me come for the question. Question is now, it is very, very easy. But whatever we have studied so far from the hybridization, it is not applicable here because this is a organic compound. In the organic compounds, our ordinary method of adopting this, the hybridization, we should not apply. So I will give you a clue here. Whenever a molecule is saturated like ethane, please memorize this, sp3. Hybridization sp3. Whenever a molecule is having a double bond, hybridization sp2. Whenever a molecule having triple bond, it is sp. Only this you have to memorize in the case of organic. Please follow, no book will give this information. This is the tricks I am giving to you. So if it is an organic compound, finally see the carbon atom where you want to predict the hybridization. You saturated carbon atom sp3, double bond connected sp2, triple bond connected sp. So now we will come easily. What they are asking regarding the pair of electron in the given carbon ion. Please follow. CH3 triple bond C is present in which of the following orbital? So is it sp3, sp2, sp, 2p? So it is sp because triple bond is connected. So if you want to predict all the three carbon atom, first is sp3. CH3 is sp3, then sp. This is the actual hybridization. So easy in the case of organic chemistry, my dear student, this trick you have to follow. Now let me go for the question number 3. Now it will be useful to you. Now whatever information I have given to you, now it will be useful to you. This is the question asked in NEET 2016. Please follow. Consider the molecules CH4, NH3 and water. Kindly follow. Consider which of the following given statement is false. Please follow. False you have to find out. Let me read now. A. The HOH bond angle in water is larger than HCH bond angle in methane. B. HOH bond angle in water is smaller than HNH bond angle in NH3. C. The HCH bond angle in methane is larger than HNH bond angle in ammonia. D. The HCH bond angle in CH4, the HNH bond angle in NH3 and the HOH bond angle in H2 are all greater than 90 degree. So these are the statements. So what they are asking, they are asking you to find out the false statement, which is false. For that, what you need now, you have to predict the bond angle of these three molecules. Kindly follow. So, CH4, NH3, H2O. I have already explained you how to predict the two methods, hybridization. So, methane, if you go according to this method, sp3, NH3, sp3, H2O, sp3. Hybridization is same. Kindly follow. But in the case now, according to valence shell electron pair repulsion theory, we have the second postulate says, if there is lone pair bond pair repulsion is present, then the shape of the orbital will change, the shape of the molecule will change. So this is 4 bond pair, there is no lone pair, so regular tetrahedron bond angle is 109.5 methane. But ammonia, 3 bond pair, 1 lone pair, you can calculate according to the formula I have given already, simple method, or you can direct 2 method I have, that's why I have already explained. From this, we can get 3 bond pair, 1 lone pair, so the shape is pyramidal, bond angle is 107. And go for water V shape, we have know already, 2 bond pair, 2 lone pair. It is V shape, bond angle is 105. 104.5. The idea here it is, methane is higher bond angle than ammonia, than water. This is the information you must get. Now you have to read the question and find out the correct answer. Kindly follow. Now the correct answer is A. Please follow. The HOH bond angle in water is larger than HH bond angle in methane. No, it is false. It is false. Because methane bond angle tetrahedron 109.28. Water it is 105. So this statement is wrong. Very, very easy you can predict. Provided you know the how to work out. This is another question. So you should be carefully analyze this question. Even though this question is asked from the inert gas elements, but coming under chemical bonding. Match the following, match the compound given in column 1 with hybridization and the shape given in column 2. In column 2, hybridization given, in column 2, shape given. And mark the correct option. See how it is the very, very difficult questions. But you can do it very easily according to my method, you can follow. Second method is very, very easy, you can follow. What way? Kindly follow xenon. So these options are given here. Option A, B, C, D. You do not worry about the options. So you can go for the calculations. Kindly follow. This question is asked under the chemical bonding and molecular structure. The topic is hybridization and shape. Please follow. Let me take now, these are the four molecules are given. Please follow. XCF6, XCO3, XCO4, XCOF4, XCF4. So, the Xc, where it is in the inert gas compound, helium, neon, argon, krypton, xenon. 1, 2, 3, 4, 5. 5 means, kindly follow, it is having 4D10, 5s2, 5p6. So what we have to do now, 5s2 and 5p6, 5s, 5p, and 5d. Kindly follow. So this is the common for all this. So what will happen now? Kindly follow. This is the ground state of all the cases. Xenon is the central atom. Please follow. Xenon is the central atom. So now we know the configuration 5s2 5p6. That is, you have to memorize easily. I have already explained you how to memorize. Helium 2, 2 plus 8, 10, 10 plus 8, like that. Atomic number also we can. So electronic configuration always S2p6 in and gas. So what is happening? First to find out how many atoms attached to central atom. That is the most important. Here 6 atom attached, so we need 6 unpaired electron. Here no unpaired electron is present. So what we have to do now? So we have to write such a way that we must have 6 unpaired electrons. 6 unpaired electron, how it will come now? So let me write now for first case, XCF6 I will write now. Please follow. So, S2, pi S2, 5p3. Kindly follow. So now what is the hybridization? Now we can predict easily. This is xenon grounds, the excited state. S, P and D. So 1s, 3p plus 3d, it is involving in hybridization. 1 plus 3, 4, 4 plus 3, 7. So S, P3, D3. So actually this hybridization is sp3. Shape is pentagonal bipyramid. Shape is pentagonal bipyramid. Please follow. This is the shape. Actual shape, there is no lone pair. Very easily without any exception, there is a one lone pair is there. Pentagonal bipyramid. But because of the lone pair, this pentagonal bipyramid getting distorted in the form of distorted octahedral. This is one. Let me come for same XCO3. Now in this case XCO3 again we need 6 electron because oxygen valency 2 to 3 into 2 6. So 6 electron we needed. Again sp3d3 is the hybridization. But only important information is out of 6 bond, that is 3 bonds are pi bond, 3 are sigma bond. 3 pi, 3 sigma. So pi bond will not do harm to that, only sigma bond will form. So what will happen now? So actually it will be the correspondingly pyramidal shape. Kindly follow how it will be X. So this will be a lone pair here. The shape will be pyramidal. So pi bond will not do harm. So it is like just like ammonia, shape is pyramidal. One lone pair. Kindly follow. So we are predicting this one. Coming for FeO, XeO, F4, again 6 unpaired electron required, 2 for oxygen, 4 for fluorine. So same configuration, the excited state. So what will happen now? Again, one lone pair is present. Kindly follow. So originally hybridization is sp3. This is kindly follow. I have already given sp3d3. It is the case. Oh, in all the cases, sp3d3. Kindly follow in this case. Okay, the three cases, all the cases hybridization sp3d3. So coming over here, so 2 pi bond and 4 sigma bond. So 2 pi bond and 4 sigma bond means, kindly follow, pi bond will not do harm. Only 4, so it will be, shape will be, it is square planar. Center is X, F, F. So lone pair, this is the oxygen and above is the lone pair. Kindly follow. So it is the pyramidal, square planar pyramidal. Square planar pyramidal because of the lone pair interaction. Hybridization is sp3d3. Same way, if you go for XCF4, you should be very careful. XCF4 means only 4 atoms attached. So I can write now 5s2, 5p6, 5d. So only 4 atoms involved means lone pair here. This is getting excited and going here, this one, and here this is getting excited going here. This is the excited state. Ground state 5s2, 5p6. So here it is 5, that is 1s plus 3p plus 2d. It is involving in hybridization. 1 plus 3 plus 2, 4 plus 2, 6. 6 means it is octahedral. Kindly follow. Shape will be octahedral. Hybridization is octahedral. sp3 d2. Hybridization is sp3 d2. sp3 d2 means it should be octahedral. But 2 lone pair is present. The shape is changing. What way? It is changing in the form of square planar. Kindly follow. F, 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 F. So I have very clearly explained the information. Now we will go for this answer. Kindly follow now. I am now summarizing all the information discussed. Species, hybridization, explained the expected shape, real shape. XF3, hybridization is sp3d3, pentagonal bipyramid. What is pentagonal bipyramid? This is the pentagonal bipyramid. Kindly follow. 5 carbon atom below and above. Pentagonal bipyramid. But because there is a lone pair, it is getting distorted octahedral. Shape changing to distorted octahedral. Fe, kindly follow. Then XCO3, again sp3d3, same pentagonal bipyramid expected shape, but the actual is pyramidal. I told you. XCFO, again hybridization sp3d3, expected hybridization, that shape is pentagonal bipyramidal, but it is changing to square pyramidal. And finally XCF4, again hybridization sp3d2, the expected is octahedral, but there is 2 lone pair, it is becoming square planar. Very, very clearly I am giving this explanation. Now we go for the answer now. What is the correct option is D is the correct answer. Please follow. D is the correct answer. So FeX6 resembling 1, XCO3 resembling 3. So if you compare, then you can easily understand that correct answer. Please follow. Next question number 5. Please follow. This is the most important. You must know again. Which one of the following pairs of species have the same bond order? Please follow. The question is asked in NEET 2017. 2017. Which one of the following pairs of species have the same bond order? A, N2O2 minus, B, CONO, CO2NO plus D CN minus CO. Please follow. Bond order means you have to get the help of molecular orbital theory. Let me explain now. So the question is asked from the chemical bonding and molecular orbital structure and subtopic molecular orbital theory. Now let me explain according to molecular orbital theory. What is bond order? Equal to half into total number of electrons present in bonding molecular orbitals minus total number of electrons present in anti-bonding molecular orbital will give you the bond order. So here I have calculated values I am giving here. Kindly follow. This is the first A, this is A, this is B, this is C, this is kindly follow. N2O2 1, see this is 2, and Cn minus and CO I have this is 3. Kindly follow. So this is the 4 pairs given. So how I am with the help of molecular orbital theory I can predict the bond order is N2 3 O2 minus 2.5. So what they are saying? Question is same bond order. So this A is not there. Then CO3 NO 2.5 O2 2 NO plus again. So this is again not. This is again not. So this is the correct answer. So correct answer is Cn minus CO. My dear students, how to predict the bond order? I can give you the tricks to calculate the bond order easily. One by theoretical, another by the mathematical way. Let me explain now, kindly follow. So let me take for example N2O, I will take example, I will explain. Kindly follow, this is the most important. This is the most important. Please follow. So you now just, this is the theoretical way of calculation. So I can now write, so this is the atomic orbital, this is the atomic orbital, this is the molecular orbital. So what I am now doing, I want to calculate for N2. So atomic orbital, this is nitrogen here, this is nitrogen here. So molecular orbital is N2. So according to molecular orbital theory, what you have to take? Only you have to take the valence shell orbital. That is 2s2, 2p3. In this case, even 2s2 is completely filled. You can neglect. Only p3 you take. So please follow the tricks now I am giving. In the case of boron, carbon and nitrogen, the p orbital is there. That is nitrogen having 3p. Again, this is also, wait a minute. So I will write such a bigger size. So to write it will be easy. So this is the N2 atomic orbital. This is molecular orbital. Kindly follow. So what will happen now? These 3p, the p means one of px, py, px, py, pz, py, px, py, pz. So 3 electrons are there. 1, 2, 3, 3, 3. So according to molecular orbital theory, what is happening now? When these 3 orbitals undergoing combination to produce 6 p orbital. So what way it will go? Please follow the technique boron, carbon, nitrogen. It will split in this form. Please follow. This is the way it will split. This is the bond pair. This is the anti-bonding. Bonding molecular orbital. This is anti-bonding molecular orbital. Anti-bonding molecular orbital. So this you have to remember. Kindly follow. So totally how many electrons? 6 electrons I am filling here. 1, 2, 3, 4, 5, 6. We have seen already. What is the bond order? Total number of electrons present in bonding molecular orbital minus antibonding by 2. So 6 by 2 equal to 3. So that means nitrogen is having bond order is 3. Please follow. Now you go for all your questions now. Kindly follow. So A is N2. Then O2 minus means how you may imagine O2 minus. Kindly follow. O means 4. So I can now write 4 means this is 4. This is also 4. That means one side O, one side O minus. Kindly follow. That means O2 minus is forming. In that case, what will happen now? So one extra electron is there. 5 electron. So 4 plus 5, 9 electron it is present. When there is 9 electron, 6 from here, then it is going here, 7, 8, 9, it is going like this. Kindly follow. So 6 minus 3, 9, 3, 1.5. So you can O2 minus is 1.5. That is the bond. The bond order is 1.5. Like this you have to follow. Kindly follow. So only I want to give a conclusion, please follow. Not necessarily draw the diagram. Only simply in the case of boron, carbon, nitrogen, you follow this technique during filling up. In the case of oxygen, fluorine and the neon like that, you can follow the technique like this. Kindly follow. This is the diagram, molecular orbital diagram you have to follow. Please follow. And total number of electrons, you have to take valence electron, you fill up one by one. First, if it is same level, share it and find out total number of bonding minus antibonding by 2, you can find the bond order. So this is the method you have to follow, my dear students. It is the tricks, easy tricks. So now the correct answer is Cn minus CO, both having 3, 3. Kindly follow. Bond order is 3, 3. It is the same bond order. I have already predicted to you. Kindly follow. Simply see here without drawing diagram. Kindly see. Carbon is 2. Oxygen is 4. 4 plus 2, 6. 6 by 2, 3. Then carbon 2, nitrogen 3, 3 plus 2, 5, 1 minus 6, 6 by 2, 3. See, that way also we can calculate, easily we can calculate. But problem is only if it is going anti-bonding, now the diagram is required. If it is only bonding alone, this method will applicable. So better you draw like I have written the 2 pattern, that pattern you have to fill up and find out. So correct answer is D. I hope I can come to the conclusion. Thank you very much for your kind cooperation given so far, my dear students. If you are coming for the first time the YouTube channel, for visiting my channel YouTube, I request you kindly click my channel and click subscribe button to motivate me, and also share this information with your friends. Dear students, I have started this NEET chemistry by Dr.R.G channel only to help poor students of India. This I started because for the last 2-3 years, simply sitting in the house, room, without going outside because of the pandemic, corona. So I want to do something new or something special to these students. So I am doing this channel for you. So please, if you follow my channel, I can give you guarantee you will get 100 out of 100 marks you will get. It is a challenge I am giving to you. So another important information I will give you. So I am running a coaching center, Vetri Coaching Center in Pondicherry for the last 20 years. Students who are studying +1, +2 and +2 completed. So for you, I have a good news. We are having a website, Vetri.S. In the Vetri.S, if you go enter into the home page, you can see all our achievement for the last 20 years. 1 or 2 let me point out. First one, in 2003, our students R. Srinivasa Raghavan came All India first rank in Pondicherry. That is All India first rank from Pondicherry Patrick School. This is the achievement. Number 2, for the last 20 years, every year our student got Pondicherry first rank, except 1 or 2 years. Maximum number of years if our students are getting. I am giving everything in the home page. Please verify. If it is not given as Pondicherry first rank, it is given in the Vetri. Vetri it will be given. That means second or third rank will be Vetri. Please follow. And most important among them all, every year 10 to 20 students are joining Jippan medical colleges. 150 to 200 students are joining other medical colleges. Few students are joining IIT, hundreds of students joining other engineering colleges. So if you want join and to become success to become a doctor, is the low cost, only 10,000 rupees you have to pay per year for all the 4 subjects. And we have 200 video lesson, 200 unit tests. Please follow. So these vetted daughters has 200 video lesson, 200 unit test. All video lessons are taken by professor with a doctorate degree and 20 to 30 years of experience teaching in medical IIT. Also teaching BSc, MSc and MPhil students, PhD students. So you can feel classroom coaching, and there are a lot their experience. You can have idea, lot of informations. And then when you are viewing the video, there is a provision given. You can touch the video, stop all the notes you can take. Just like what I am taking, it will be. All notes you can take and then touch, it will move. It's just like YouTube. And this vetted daughters is containing 200 unit tests. Please follow, each unit containing 2 tests, 45. All the questions are taken from previous question papers of IIT, AIMS, AFMC, AIPMT, MSET, Andhra, Delhi, Karnataka, Tamil Nadu, Pondicherry, etc. So what is the interest information for this? Why we have taken all these questions for the framing of 200 unit tests? We observed for the last 6 years in the NEET chemistry, 75 to 80 questions are same questions repeated. That means 320 marks you are getting from vetted daughters. Then if you get 300 plus with your own the personality, then you will get 650 to 700. You will become an all India rank, get all India rank and become a doctor. You can join anywhere you want. She is the low cost. Please follow. And another interesting information there, 200 tests when you write, each test you can see your answer is correct or wrong, facility is available. And also each and every question discussion, video solution, all these facilities not available in anywhere. Please visit, there is a free course is also there, and experience, then you can pay 10,000 rupees if you want and join. In the name of Santi Vetri Coaching Center, Director Vetri Coaching Center, Indian Bank 71, account number 712719471, IFC code IDIB 000P134, cell 989417645. So, thank you very much for the kind cooperation. See you again in my next discussion. Tricks to